Okay. So,
Hello.
yes, yes. Can you hear me now?
Yes, sir.
Yes, sir.
This venturimeter tube is used to calculate the Q value. Q value means the volume flow rate inside the tube, right? As I've told you that if this is a tube, there is a hole. You can measure at Q at different places, and you can find that if Q is less at some point, then in between these two places, you can only dig to find out the hole. How it measures the volume flow rate Q, you can look to this diagram. Suppose there are 2 points on a streamline I will take. One point is A, another point is B. A point is just above this tube of this manometer, the vertical tube of this manometer. B point is just above this vertical point of the manometer, right? And you can also say that the distance between them is also taken, although it will cancel out, I think. Suppose this height is HA and this height is HB. Manometer uses a mercury liquid to find out the height difference. Right. So, what is the working principle? If you look to the points A and B lying on a same streamline, points A and B, then I can find the pressure at point A plus half rho VA square is equal to pressure at point B plus half rho VB square. Which velocity will be large? Velocity at A and velocity
VB.
VB. So pressure at A will be smaller than pressure of B. From simple
So A. So that's from continuity you found out.
equation.
So
Yes, definitely. It's
So
from
that's
continuity.
okay, sir.
in case that liquid is not flowing out.
Yes.
So that is the case when the liquid is not going out from the hole.
Yes, yes. No, I'm not actually calculating at here. I am calculating here and here. I have to find the Q value only, not at the hole position. So there is no hole here. It is a one end of the tube and another end of the tube, and you connect a venturimeter in between them, right? So you can see that this is the liquid
Yes, sir.
flowing, and what you have done this narrow cross section deliberately only to make a pressure difference between A and B, right? So if I can make a pressure difference between A and B, that pressure difference will actually lead to another pressure difference inside the manometer. Yes or no? How? You can directly say that I am finding this pressure now. Suppose at this point, C and
HA into rho into G equal to HB into
yes.
uh,
Suppose this point is A prime and this point is B
rho
prime,
into B.
right? A prime and B prime. Suppose these 2 points are A prime, B prime. So now can I say that pressure at A prime, do you remember that if I move perpendicular to the streamline, how the pressure changes? From A to A prime, I am moving perpendicular to those streamlines, which are parallel straight streamlines. So do you remember that? Perpendicular to the streamline, only the pressure changes as hydrostatic. So it is PA
Rho G.
plus rho of the liquid inside into GHA. Similarly, what is PB prime? PB plus rho GHB, yes or no?
Yes, sir.
From manometer tube, from manometer, can I say that the pressure difference of A and B prime, pressure difference at A and B prime is nothing but rho mercury into GH?
Absolutely, sir.
Yes, sir.
Rho
Now,
mercury means difference of mercury
column, yes,
height, that
difference
one.
of the mercury column
HM.
height.
HA
So,
minus HB.
yes, now you can easily see that rho PA prime minus PB prime is equal to PA minus PB, which is half rho VB square minus VA square, right? Plus rho G HA minus HB. What is HA minus HB?
It's HM.
It's HM only. So I can say
Absolutely.
that now I'll move here. Half rho VB square and VA square. There is a relation between VA and VB, right? So before writing this equation, let us, can I write that area of cross section at A, suppose it is
A1 and A2.
A1 into VA is equal to A2 into V2 VB,
Yes, sir.
and A1 A2 are known to me because I can measure the area of cross sections at A and B.
Given to me.
Yes, so I can say that if I use this formula now, it is half rho VB square. If I take it common, 1 minus, now VA is equal to A2 square by A1 square into VB square. That is equal to rho mercury minus rho of the liquid into GH of mercury. Right?
Please wait a bit. Yes, sir.
Yes, sir.
So what is LIGO projects?
These are different names. Don't concentrate on these different names. Only the working principle is important. So VB is equal to 2 rho mercury minus rho liquid divided by rho liquid to GH mercury and whole divided by A1 square minus A2 square into A1 square, right? So A1 I will take outside here.
A1 square. Okay. We were taking this one.
Right, look, all the terms are known inside this term VB. So as I know VB, then what is the value of Q? Q value is equal to A2 VB.
Yes, sir.
So it is A1 A2 under root of this entire term is there, 2 rho mercury minus rho into GH of mercury divided by rho into A1 square minus A2 square. Right, that is the Q value that you will measure. Now different instruments are there. You can easily calculate all these things. They are given and you can calculate the value of Q.
So please wait a bit. Done, sir.
So please wait.
Yes.
So this is used for calculating this volume flow rate.
Yes. If density of the liquid, if you find it is very small compared to the mercury, then sometimes rho mercury minus rho, you can only take rho mercury one. Right? If you
Okay, sir.
if it is written in your question or the data, you can find that it is very small, you can approximately find your answer. Okay, I think we have done it.
There's sometimes.
Yes, sir.
Yes. Oh, yes. Actually, I got badly affected by this flu that is going there in Kolkata. Once I
So
came
now you're
here,
affected by flu.
yes, not that coronavirus, I think, but I got affected by this local
Yes, flu.
flu virus. Yes. So right now
So have
only.
you went to a doctor?
No, I've not went to any doctor because I think it's only because all the other symptoms are not there. Only it's a running nose and fever. So that is the only problem
Flu
I
is
have.
normal thing.
So, but
Yes.
you should go because it's never.
Yes,
We should never
it's
take any
sometime,
risks about
yes,
it.
asymptotic. So I will wait for 1 2 days. Then definitely I will go for a test.
Flu
Durgapur
is
is
common.
way better actually. Kolkata, there is 80% locality here in Damdam where I actually stay there. Got affected with that flu. Some types of flu are there, dengue or
So
whatever is
your
the flu.
real house is there only.
Yes, near airport Damdam. Okay, so we have done this one. That is an interesting question. This is a pitot tube arrangement. Right, look, there is a small tube that is a bent tube, manometer. It is only a manometer where mercury is kept. Right. Now I have placed this manometer in three different positions. Look, three different positions are there. So you have to just tell me
Hmm.
that if I say that at the pressure inside the gas, inside this tube, a liquid is flowing, a gas is flowing basically, the pressure of the gas is suppose Pg. Right? Inside the fluid, the pressure of the gas is Pg. And outside the atmospheric pressure is there. Outside atmospheric pressure is there. Can you tell me what is that rho mercury G into H mercury represent? What does that, if this is H, this height is H, suppose this height is H1, this height is H2, and this height is H3. So
So please
just,
wait a bit.
yes, your question is what does rho mercury GH represents?
So H is that H1, H2, H3. So
Yes,
there are
in
three
three
different
different
conditions.
cases, they will represent three different terms. It may be P
Sir,
gas minus P
so is it the
atmosphere. Yes,
gauge pressure?
in the first case. First
No,
case,
so not in first case.
not all these
In
three cases. Three cases will have different value. Let the velocity of flow is V also given. These three cases will have three different values. The arrangements you
okay,
can
sir. Okay.
understand.
So one more minute, sir.
Sir,
বলো
স্যার মানে আনসার গুলো কি আমরা ম্যাথমেটিক্যালি পাবো না মানে ভেবে ভেবে অ্যানালিটিক্যালি পাবো?
না ক্যালকুলেট করে বলো কি ভেজা
না পুরো জল জল করে মুছে
এখানে তো কিছুই করতে নেই।
ঘুমাবে ও কি ঘুমাবে
ওইখানে ঘুমোতে পারবে না ওই ঘরে যাও টিভি
হ্যাঁ যাচ্ছি সব ভিজে
Sir, I'm getting hilarious answers. So may I say,
Yes, tell me what's your answer.
sir, in first and second I got PG minus P naught, and in third I got 0.
Okay, look, in the first case,
Sir, one thing.
yes,
Sir, will the answers in the first and second be equal?
no, all the three answers will be different.
Oh no.
Look, in the first case, you have got a situation like this where if you find the pressure at this point, it is P of gas only,
Yes, sir.
right?
Yes, sir.
But if I come from here to here, so at this point I will also find the pressure at P of gas.
Yes, sir.
If I neglect the pressure change due to this height,
So why are we neglecting? Oh, it's not liquid, that's why.
yes, there's a gas, always you can neglect it.
Density is low.
So this height is H and this point pressure is P naught or atmospheric pressure.
Yes, sir.
So what does that rho m into GH represent? Only Pg minus
Gauge pressure.
Yes, the gauge pressure. Gauge pressure sometimes also known as static pressure. Right? It is Pg minus P naught. Basically, it is a gauge pressure. We can also say that. In the second case, the situation is that you have bent the pipe inside the gas. So as soon as you bent it, the liquid, there is a streamline that will come like this.
Okay, sir.
Yes, sir. Yes, sir.
Right? So you have to take this streamline now.
So I didn't think about streamlines.
Yes. We have understood the concept of streamline. So always think about a streamline when you are dealing with Bernoulli. Now you can see that at this point the velocity of the gas particle is 0. And at this point the velocity of the gas particle is v.
Yes, sir.
Yes,
Yes,
sir.
sir.
So if I say at this point 1 and this point 2, then what is the pressure Bernoulli between 1 2 I will write? Can I
Yes,
say
sir. You can write it.
Pg plus half rho v square is equal to P2?
P2. Yes, sir.
And this is P naught again. So what is rho mercury GH represent? It only
So
represents
it represents.
P2 minus P naught or not?
Yes, sir. Okay.
So
Okay.
what
So
is-
this gauge pressure minus that what you said.
Yes.
Energy pressure. That one.
So P2 minus P naught is Pg minus P naught plus half rho v square.
Plus.
Right? So it is static pressure plus this pressure is known as dynamic pressure. Dynamic pressure, half rho v square. This pressure is coming due to the velocity. So it is nothing but the total pressure, you can also say. That is why it is
So
written.
in that first one, why no streamline came? There also it is connected. It could
No,
have
it is
come
not
through.
connected. Why the streamline will flow here? It will directly flow. If you throw a particle here, with this velocity, the particle will come here only. It will not come down here.
Okay, means it's not coming in
the
the
gas doesn't come down
Yes.
there, then how can we get the pressure at that place?
No, the gas is still there. Gas was initially
gas
there.
is
It
there,
is
but
still
no
there.
motion.
There is no motion of the gas
Oh,
inside.
okay, okay, sir, I get it. I get it.
Right. So there is only this due to
Initially, when the gas was left, then some part of it was occupied, and then the gas flowed in that way.
yes, and that part remains still. It is at rest. There is no flow here.
Uh,
Third part is very simple. Can you see in the third part, this pressure is also P gas?
Yes, sir.
Sir, in one way there's dynamic, and other way there is only static.
Total, yes, and static. So this is the situation in the third case. In third case, you will find this streamline is coming down like this, just like the second one. But this pressure is no longer P naught. This pressure is P gas. Just like the
Yes.
first situation. Yes or no?
And that one is PG plus half rho V square.
Yes. And that is Pg plus half rho V square.
Yes, sir.
So if I subtract their values, then I can find that rho mercury GH is equal to what?
So it is half rho V square.
So it is only the dynamic pressure.
So please wait a bit.
আচ্ছা আমি বলছি
So that you have mentioned in that first one, that can you please repeat that velocity will go in right order?
Velocity will go where? The first situation.
Means that no dynamic pressure, first part. That one can you repeat once more?
First part, because this pressure is only Pg and I cannot find a streamline between these 2 points. Streamlines are perpendicular to this. As I am moving perpendicular to streamlines, there is no role of the velocity involved.
Okay, sir.
It will only be as it is a hydrostatic nature, and there is no terms in the of the
I mean,
velocity.
before when velocity was 0, that time everything was PG. Then after that, one part got the dynamic pressure and that part didn't get.
Yes, yes. That part is at rest only.
স্যার
হ্যাঁ বলো।
স্যার সেকেন্ড আর থার্ড কেসে যে ওখানে এয়ারটা ফ্লো করে ঢুকছে, তো ওটা একটা স্মল, মানে যে পাইপটায় ঢুকছে ওই পাইপটার রেডিয়াসটা তো ছোট, তো ওখানে এরিয়াটা, ক্রস সেকশনাল এরিয়াটা ছোট হয়েছে, তাহলে ইকুয়েশন অফ কন্টিনিউটি লাগবে না?
না, ইকুয়েশন অফ কন্টিনিউটি তুমি এই পয়েন্টে চেঞ্জ করতেই পারো। এই পয়েন্টের প্রেসার ভেলোসিটি আলাদা হতে পারে। ইকুয়েশন অফ কন্টিনিউটি এখানে কেন লাগাতে পারবো না? বিকজ লুক, ইকুয়েশন অফ কন্টিনিউটি তখনই হবে যখন তোমার স্ট্রিম লাইন চেঞ্জ হচ্ছে। ডু ইউ নো দ্য এরিয়া অফ দিস এয়ার ফ্লো? Can anyone tell
No,
me
I
why
don't know.
equation of continuity I cannot use here? Here you cannot use equation of continuity. If the situation would be like this, then you could have used the equation of continuity. Yes or no?
তার মানে পুরো হাওয়াটা ঢুকলে তখনই আমি
পুরোটা যদি এখানে ঢুকে যেত, তাহলে এই পুরো যতগুলো স্ট্রিম লাইন এর ভেতরে ছিল ততগুলোই এর ভেতরে ঢুকতে হবে, তার জন্য এর ভেলোসিটি বেড়ে যেত।
কোনো আউটফ্লো হলে হবে না।
কিন্তু এইখানে actually if you look what is happening, there is no change in the shape of streamline. If there were 10 streamlines here, out of 2 streamlines only get inside it, right? So their velocity will not flow change according to the continuity equation.
So it will remain the same only.
Here the velocity will remain the same. Inside what is happening, that you have to find if the pressures at different points are different, then you cannot say that inside is everywhere same, or inside everywhere the pressure may be zero. That may also
Means we
happen.
are finding V just outside the aperture.
Yes,
Can you say
yes.
like that?
That is also a streamline, so I can take V here. I am not bothered about all the points. I am only bothered about this 1 point and 2 point.
Okay, sir.
Right?
So this is only the pitot tube.
Yes, it is a pitot tube. It is used in several places to measure the velocity of an airplane. To measure the velocity of airplane, this pitot tube, the third configuration, is used. Right? This is the inside aeroplane actually, and this is outside air. So with respect to aeroplane, this situation is happening there. Air is flowing, and there is a pitot tube like this. So with half rho v square, you can measure rho gh, and velocity you can easily find from this pitot tube. Now it says that water is flowing in a stream at a speed v. Water is flowing at a speed v. A L-shaped tube is lowered into the stream. The upper end of the tube is held at a height h0 above the surface. To what height h above the upper of the tube the water jet will move? assume that the flow remains ideal.
Sir, that is the maximum height.
Yes, the maximum height of the flow.
Sir, will the answer be v square by 2g minus h naught?
Yes, something like that.
Sir, please. 1 minute, sir. So may I try?
Yes, tell me what's the answer.
Sir, v square by 4g minus h naught by 2.
Okay, look, at the topmost point, what is the velocity of this fluid? 0?
So it's v1 you can take.
0 at the topmost point. Why it will be V1?
Yes,
Oh,
sir.
at h though. I thought at that pipe opening.
হ্যাঁ বলুন। হ্যাঁ ঠিক আছে ঠিক আছে। আপনি কি ডেসিম রেঞ্জ দিয়ে বসিয়েছেন না শুধু কারেক্ট আনসারটাই বসিয়েছেন? কারেক্ট আনসারটা বসিয়েছেন তো ঠিক আছে, আমি রেঞ্জ করে দেবো, আমি রেঞ্জ করে দেবো। At topmost point this velocity is 0 and you can see this velocity is v, right? Inside whatever may be the velocity, whatever may be the pressure, I don't want that. Only I am concerned about the topmost point and this bottommost point. What is the pressure at the topmost point when the liquid is outside?
P naught.
P naught, atmospheric pressure. What is pressure at this point if the height is h1, suppose?
So
What-
take it to be x.
Is it P naught plus rho g h1?
Yes, sir.
Yes, sir.
Because I am coming perpendicular to the fluid flow.
Yes, sir.
Right? Fluid is moving in this direction. And this height, what is this total height?
H naught plus h plus x. Sorry, h1.
Yes. Now let us apply Bernoulli between 1 and 2. Half rho v square is 0 plus p naught plus rho g h naught plus h1 plus h is equal to half rho v square plus p naught plus rho g h1.
Yes, sir.
So h1 will get cancelled.
P naught plus
P naught
rho
will
g
get-
h1 will get cancelled. So the value of h you will get is equal to, and rho will also get cancelled, I think, rho half rho v square. This one, so p naught gets cancelled out, rho g h1 will get cancelled out, rho will also get cancelled out. So h is equal to v square by 2 minus h naught divided by g.
Whole into 1 by g.
Sorry, v square by 2g minus h naught.
Yes, sir. will not
v
be
square
whole.
by 2g minus h.
So
Right?
my answer came the half of this.
Yes, sir.
So look, I only have to find the points, choose the points.
Hello?
Where, yes, can you hear me?
Yes, sir.
I only have to choose the points where I have to find the velocities. Otherwise, intermediate points, whatever it is going on, you don't have to bother about that. Okay, now we will talk about velocity of efflux. What is velocity of efflux? Uh, Suppose there is a container.
So these are Bernoulli's equations applications.
Yes, all of them are applications. Suppose a container is there, you have filled the liquid up to this height, and there is a hole at a depth h. As we know that as soon as we open that hole, liquid starts flowing out, right? So with respect to this container, the velocity of the liquid is known as velocity of efflux.
স্যার
বলো।
স্যার আমি ওটা জিজ্ঞেস করছিলাম যে মানে যেটা পাঠিয়েছিলাম না যে আউট অফ সিলেবাস যে কোয়েশ্চেনটা
হ্যাঁ,
ওটা এটার উপরেই ছিল।
ঠিক ঠিক ঠিক। Velocity
Yes,
of
sir.
efflux. হ্যাঁ। So velocity of efflux is the velocity of fluid coming out from this small hole. How do I find it? Now you can assume any streamline. Suppose this is a streamline. I can assume this to be a streamline.
Yes, sir.
There is a point at the surface and there is a point just outside this hole, right? This outside point is 2, this point is 1. Can we apply Bernoulli between 1 and 2?
Yes,
So we
sir.
can apply.
Yes, sir.
What is velocity at point 2? VE. Now what will be velocity at point 1?
Sir, it's 0.
Nearly 0. Why? Because if you apply,
Negligible change in level of water.
yes,
খুব
a
আস্তে আস্তে
v1
নামবে
is equal to
লেভেলটা।
small a v2, then v1 is equal to small a by capital A v2. Now capital A is much larger than small. You have punched a very small hole. So in that way, can I say v1 is negligible in compared to v2? So when I apply Bernoulli, I will find what is pressure at P1
P naught,
and what is pressure at P2.
P naught.
P2 is also P0. So you can say P1 plus half rho V square plus rho G H is equal to P2 plus half rho V square. Can I write this equation?
Yes, sir.
P1, P2 gets cancelled out. V2 you will directly find root over of 2gh, a very well known formula that we have already done in mechanics, that if you release a particle at a height h, then it will hit the floor with the root 2gh velocity.
Yes, sir. Sir, here it is coming because the pressures are same.
You can say the pressures are same. So if you conserve energy, then no work is done actually, right? This pressure and this pressure are the same.
No work is done by what means?
The external forces. Here the
Yes,
external
sir.
force is pushing downside. It is doing a positive work. Here the external force is pushing left side. It
Pulling.
is doing a Yes, it is
Okay.
pushing. External force is also pushing. Always
Pushing.
pushing. Pressure cannot be created by a pulling force here in liquid.
Yes, sir.
Shouldn't the container be moving to the other side because of the
Yes,
water?
yes, yes. That may also happen, but here I have told you that velocity of efflux is with respect to container only. With respect to container, when container is at rest, and I have
Sir,
neglected.
like we did like falling chains and all these
Yes,
questions.
yes. Definitely, there is a thrust force like rocket propulsion, if you remember.
Yes,
Yes,
sir.
sir.
Yes. So that also can happen here, but that is negligible because I have assumed the mass of the bucket is so large that this force cannot actually move it, right? But again, we can do it. We can find that calculation also,
Hmm.
right? So what I was trying to say that
This
as
is the
the
negative work are same.
yes work done are the same, so I can only conserve the energy, which is definitely say this one.
স্যার
Yes.
স্যার স্যার ওইটা দেখাবেন যে যদি মানে যদি কি বলবো মানে এ যদি নট ভেরি ভেরি গ্রেটার দ্যান
করবো
স্মল এ
করবো।
আর যদি মানে কনসিডারেবল অ্যামাউন্ট অফ লেভেল ওয়াটারে চেঞ্জ হয় তাহলে কোন ফর্মুলাটা আসবে?
তাহলে ভেলোসিটি অফ ইফ্লাক্সের ফর্মুলা একই আসবে যেখানে আমরা ভেঞ্চুরিমিটারে ক্যালকুলেশন করেছিলাম, মনে আছে?
So please repeat.
We have done a calculation on venturimeter. The velocity was
Yes, sir.
function of a1 a2.
Yes, sir.
Yes, so if the a1 and a2 are not same, not negligible here, small a not negligible compared to capital A, you will find the same formula, similar formula that we have got here. Right. You can try that only, no problem. Only you will solve it by this calculation. One
That
second.
continuity and Bernoulli.
Hello. কম্প্রিহেনশন দেওয়া আছে তো ওখানে, আমি তো অ্যাড করে রেখেছি। হ্যাঁ, প্যারাগ্রাফে শুধু কোয়েশ্চেনটা কাটুন, শুধু প্যারাগ্রাফটা কেটে কম্প্রিহেনশনে ঢোকান, ট্যাগ দিয়ে দেখার দরকার নেই নিচে। তারপর আপনি কোয়েশ্চেনে যখন দেখবেন তো কোয়েশ্চেনগুলো কেটে কেটে বসাবেন। হ্যাঁ হ্যাঁ, হ্যাঁ বলো।
Yes, sir, it's okay.
In that case, you will find a complicated answer. That is actually not needed. No one will ask you that because that is only a calculation. Nothing new on that.
They're not also in advance.
No, it is an advance only. No problem. Even if you do it, it's a by 2, a by 3, you will not neglect
It's
it.
a venturimeter problem. Conventional.
Yes. The
Yes,
same
sir.
calculation will be there. Try to solve this. In our arrangement shown, the tank has a larger cross section. Pipe has much smaller cross section. Opening A is unplugged and the water jet hits the ground at a horizontal distance x. Find the x. The second question. The first question says what is the height of water level in A in the tube B. A very simple question. Try to answer it. Okay. Look. If I take one streamline that is started here and inside the tube that is going, can I take one such streamline like this?
Yes, sir.
Yes, sir.
Let us assume this point and this point. What is pressure? This point is B prime and this point is A. Velocities of these 2 points, are they same or not?
So
Yes,
which
sir.
point on that photo?
A and B. This is the I have taken a streamline like this. Between A and B I am talking about. A and B both are inside the tube.
B prime to কোথায় আছে, sir?
Inside the tube, just below this.
Just
tube.
below B.
Yes. Can you see that the velocity of A and B both are the same because they are inside the
Yes,
same
sir.
tube. So, and there is no such height difference also at A and B prime.
Yes, sir.
So can I say pressure at A and pressure at B prime both are same and that is equal to atmospheric pressure?
Yes, sir.
Yes, sir.
So the
So
height
please
is
wait a
equal
bit.
to 0?
This one. So B is a point B prime is a point
Sir,
vertically
will it-
downwards of B.
Yes.
Sir, won't it be P naught plus rho GH?
Yes. So if it is P naught plus rho gh, that is equal to P naught, then what will be H? If you come down from here, then before finding H, you can also say that PB is equal to P atmosphere. And
Yes, sir. Yes, sir.
B
Sir,
plus rho gh is equal to PB naught, PB prime.
Yes, sir.
So how is PB prime atmospheric pressure? That
Hello?
part once say.
1.
Yes, sir, that is the question.
কোনটা করা হয়ে গেছে? আচ্ছা,
হ্যালো।
ঠিক আছে, তাহলে তো সবকটাই হয়ে গেছে। ঠিক আছে, ম্যাথসও হয়ে গেছে সবকটা। একবার দেখে নিন তো, মান্টু বললো সব হয়ে গেছে। হ্যাঁ, বললো তো 3টেই করে দিয়েছি। I am saying that if this is a tube, take this point A and take this point B. So velocity of the points A and B must be the same.
Yes, sir.
And if you apply Bernoulli equation, you can
Okay,
say
then it will be P equal to PB.
yes, PB plus half rho VB square.
Yes, sir. Yes, sir.
Yes, plus
Yes,
rho
sir,
GH
understood.
is 0. H is 0, not a height difference. So that is equal
Yes,
to
sir,
PB
H
plus
will be
half rho
0.
VB square. So they are the same. VA, BB are same. So PA and PB are same.
Yes, sir.
Right. So in horizontal pipe, the pressure is same actually. In horizontal pipe, the pressure remains the same.
Yes, sir.
What is the value
If
of
H is 0, means that there will be no height.
No. How can there be any height if H is 0?
Yes, because both are at atmosphere.
Both are at atmospheric pressure. So no one is going to balance the weight if you balance the
Sir.
force equation.
Sir, if the A part was closed, then it would have raised to capital H.
Then it is
Sir.
different. If A is closed, then there is no water flow. Then it is a hydrostatic condition. Everything will be in hydrostatic condition in that case.
Sir, my question is A and that perpendicular erect pipe, means A and that pipe, are they very close?
What does if they are not very
It
close?
doesn't matter, I guess.
Will it matter? I think no.
No, sir, it won't.
Even if it is here, the velocity will be the same because it is the equation of continuity that I have written.
Okay, sir. Oh, what am I doing?
Right? In order to find x, it is only a projectile motion. The velocity is root 2 gh or not?
Yes, sir.
Root 2 gh. So it will come down here after covering a range x. And if this height is h naught, I can find the time taken is equal to root 2h by g.
Yes, sir.
So x is equal to root 2 gh into t. So equal to root 2 h naught.
Sir, please wait a bit.
Total height of the liquid column is suppose h prime.
H prime.
So what can I say about the value of x?
Okay, sir. H plus H. Okay, I got it. I was not. H
Right.
plus H naught by 2.
Yes, x is equal to 2 root over of h prime minus h naught into h naught. Yes or no?
Yes, sir.
So if you differentiate it with respect to h naught, then you will find it is coming h naught is equal to h prime by 2. For maximum range, you have to punch a hole at the middle.
So please wait.
Yes.
Sir, the value of H naught will be H prime by 2. Okay, okay, sir. Okay.
Yes, sir, done.
Done this one. Okay. A large cylindrical tank has a cross section area capital A. It has a small orifice at the bottom of area small a. Initially, the liquid of density rho is filled up to a height up to a depth h. Find the time to evacuate the container through the hole.
Okay, sir. So may I try?
Yes, tell me what's the answer?
So 2 into capital A into root over small h divided by small a into root over 2g.
Yes, I think. One second.
Sir, but I have a negative sign with me.
One second. Look, let us assume this is your container and there is the hole at the bottom. Liquid is here. At certain high instant, the liquid level is y. From bottom, you are measuring the liquid level. So what is the velocity of efflux? Root 2 gy. If this area is A and if this area of cross section is small a, from continuity what we can say?
It is
A into
capital A.
dy by dt is equal to small a into root 2 gy. Can I say that?
dy dt is that small velocity to with which the level is coming down.
Yes. Look, here I have to put a negative sign before dy dt. Why? Because the velocity is coming negative downward and y I have measured upward. Or you can say that with respect to time y is decreasing. Yes
Okay.
or no?
So please wait a bit. Just
So now I will just modify this function.
another one is what said, sir? Means negative y direction.
Yes. Y is decreasing with time. Another one is velocity is downward and displacement is upward. So velocity should be negative of dy dt. So that is equal to minus dy by root 2 gy is equal to small a by capital A into dt. Now you can integrate it over time 0 to t and over y h to 0. Right, so that will be 2 root y. So 2 root over of 2g into root over of h is equal to a by capital A into t. So t is equal to capital A by small a into root over of 2h by g.
So 2 by root 2g, what you did that?
Root 2g I have taken out. 1 by root 2y. What is integration of 1 by root y? 2 root y.
1 by 2 into root y.
1 by root dy by root y. What is the integration of dy by root y?
So it is 2 into root y.
Yes, so I have taken this one only, 2 into root y.
Okay.
Is that the answer you have got?
Yes, sir, I have got this.
Yes.
Yes, sir. I also got this. So please wait a bit. Right, you. Yes, sir. Done.
Okay. Now these are two liquids of different densities are kept in a container. What is the velocity of efflux? If the heights are h1, h2 respectively given. This height is h1, this height is h2.
So may I try?
Yes, tell me what's your answer?
Sir, root over 2 into rho 1 gh1 plus rho 2 gh2 divided by rho 2. This whole root over.
Yes. I can take this streamline that starts from here and that ends here. This point is A and this point is B. Now that is only purely inside a liquid of density rho 2. Yes or no?
Yes, sir.
Yes, sir.
Yes. Now one thing you should understand that this entire part inside the tank is moving with a very small velocity or negligible velocity. Yes or no?
Due to big area.
Compared to the this yes area. So as I can say that the velocity inside is very small, I can say that this entire part is in hydrostatic condition. Can I say that? This entire part is hydrostatic.
Yes, sir.
Apparently, it is static.
Yes. As it is in hydrostatic condition, so I can easily find the pressure at this point A, which is simply P naught plus rho 1 g H1.
Yes, sir.
Okay.
Right? I have not applied Bernoulli actually. I have applied a hydrostatic function here. Pressure at B, it is P
P
naught.
naught. Yes, sir.
Between A and B, I will apply Bernoulli. So can I say P naught plus rho g H1? This is pressure. Plus half rho 2 V2 square. V square, V is 0 here.
Yes, sir.
Plus rho
Rho
g
2 gh2.
H2 is equal to P naught plus half rho V square.
Yes, sir.
Rho P naught gets cancelled out. Right. So I think V2 is equal to,
Root under of 2 rho 1.
yes, that will get cancelled out.
So what will get cancelled out?
This is 0. P naught gets cancelled out.
P naught.
So VE square is equal to 2 by rho 2 into
Rho 1
rho
gh1
1 GH1 plus rho 2
plus rho
GH2.
2 gh2.
So please wait.
Yes, sir.
Please wait, sir.
Have you got it?
Yes.
So if the velocity was appreciable, then pressure at A will be that from apparent one.
No, if the velocity is not negligible, you have to first find Bernoulli from this point to this point, and then you find pressure at this point.
Means we will apply Bernoulli separately.
Yes. Then from here to here, you apply another Bernoulli, not from this to
Bernoulli from where to where at first?
from this point to this point. From inside one liquid, you apply Bernoulli.
Okay, sir.
This question says a large container has a tube of non-uniform cross section as shown. Free end of the tube has a radius of radius small r and depth is h from the liquid surface inside the water. This free end it is talking about. This free end is at a depth small h and the radius small r. Bigger cross section has a radius capital R and that has decreased to smaller over a length L. What is the pressure inside the tube as a function of x? Not static, only find the pressure.
Pressure
Static means
inside the tube as a function of x.
Yes.
Okay.
As a function of x. X is measured from this end. Right?
Okay, sir.
For
Doing.
calculation purpose, you can take small r is capital R by 4. Suppose like this.
Sir, this is R linearly over a length L.
Yes.
It's length of the tube, though.
Length of the tube. Yes, the length of the tube is capital.
Okay. So please. Sir, is that area of the tube appreciable with respect to that of the tank, width of the tank?
Okay, how do I solve it? Have you got it?
Sir, some more time you give, sir. 1 minute. So please don't solve, sir.
Yes, yes. I'm drawing the diagram.
Please, sir.
What is y in terms of r?
Sir, please wait, sir. Y in terms of R. So Y, I'm saying it's R minus 3 into capital R into X divided by 4 into capital L.
Y is equal to r by 4 plus this distance. Now this distance is equal to this length, which is L minus x, multiplied by tan theta. Now tan theta is 3r by 4 divided by L. Right? Tan theta is equal to 3r by 4 divided by L. So I think that is equal
May I
to
try
1.
the answer, sir?
Yes. Tell me.
Say will it be a bit big?
Yes, yes. The answer will be a complicated one.
So I got, I'm saying P naught minus rho G into H into 1 minus capital R square divided by capital R minus 3Rx by 4L whole square. Something like this.
Okay, let us check. So it is y.
So this
Y
sum
as
can you
a,
explain from first, sir? This
uh-huh.
sum. This sum can you explain from first?
Yes, yes. I'm finding y. Y you can find from this triangle, right? If this angle is theta, then tan theta is equal to 3r by 4 divided by L. Then this height from this triangle, smaller triangle, this small height is equal to L minus x into tan theta that I have got, and so the y is equal to r by 4 plus this one. Now I have to find the velocity at this point. velocity at this point, suppose this point is A, then velocity of this point A,
Sir,
bolo,
sir means how you found out that part I am not getting.
which one?
Y equal to that one. It varies linearly.
It varies linearly, yes.
Okay, after that means
1 second. This Y, can you see this this tan theta from this 3r by 4 divided by L? From this small triangle, this part height is equal to L minus x into tan theta.
yes, sir. Yes, sir.
So Y is equal to r by 4 plus this one.
What is the constant?
Constant means r by 4 is constant throughout this. Linearly it is varying, means there is not a equation it is following. The equation is
Okay,
this
sir.
one.
Okay,
The
sir.
equation I have got this one.
The tan theta is 3r by 4l, no?
3r by 4l.
Yes.
Yes,
Okay, sir.
tan theta is 3r by 4l.
Then what you have done in that? So r by 4 into 4 minus 3x by l.
Yes, r by 4
Okay.
into 4 minus 3x by l. Then from continuity, can I write this equation? VA into pi y square is equal to root 2gh into pi r by 4 square, because the velocity at this point is root 2gh.
Yes, sir.
So I thought the velocity at that left cross section is root 2gh.
Here, no, here the velocity is not root 2gh. This
Oh,
height is
so
not here.
I calculated everything from there only.
Not here. Why I cannot say? Because this pressure, I know I cannot say it is the atmospheric pressure here. Atmospheric pressure only this one.
Okay, sir.
At the end, this point is atmosphere.
And why can't we apply Bernoulli's equation here?
You can apply. I've got the 2gh from Bernoulli equation only. Which point you want to apply Bernoulli equation? A, B, C, which point?
Sir, means the streamline will be from that top part of the tank, and then it will be
Suppose this
in
top
that
part
last
is
point C.
B, yes. It is B,
But that is a derivation though.
it is A, it is C. Anywhere you apply Bernoulli, you will only find this velocity of it.
Okay, sir.
Right. So VA, I have got this one. Then I can find what is the what it is asked. The question is asking find the
Pressure at
pressure.
function.
So what is pressure at point A? Now can I use Bernoulli at A and C? You can also apply at D and A, no problem. At A and C,
Okay,
can
sir.
I say PA plus half rho VA square is equal to P naught plus half rho V square is rho GH.
P naught plus rho gh, yes, sir.
Rho GH means it
Yes,
is
sir.
half rho V square basically. If you say it is half rho into root 2 GH square.
Yes, sir.
Yes.
Yes,
From
sir.
there I can find what is PA, because all the terms are known to us now. PA is equal to P atmosphere plus half rho into 2GH minus VA square. Now VA square is equal to 2GH into R power 4 divided by 16 square, I think. 16
Yes.
square
Yes,
root
sir.
256 y to the power 4.
256 y power 4. Yes, I
So
think
you
that
could have taken that one also out, that 2gh.
2GH also you can take it out. So that is your answer. 2 you can cancel. So P naught plus rho GH into 1 minus R power 4 by 256 y power 4.
Which is good.
And also
P naught
y
plus
is a function of
Rho
x.
gh.
Mm-hmm.
P naught plus rho gh into 1 minus r to the power 4 by 256 y to the power 4.
Yes. You can also further simplify it. Look, y is also a function of x, where r by 4 is also there, so that will also cancel. So it will be 1
We have to
by...
put that value of y.
Yes, yes.
Okay.
You have to put the value of y, you will find the value.
Yes, so that
function.
is the main thing. We have to take in terms of x.
Yes, yes. That you can also do from here. P at A is equal to P naught plus rho gh into 1 minus 1 by 4 minus 3x by L whole power 4. I think that will be your answer.
256.
That will get cancelled out. Now y is also r by 4 is there. R by 4 power 4.
Yes, sir, it will get cancelled out.
It will get cancelled out.